For the FE Civil exam, understanding the stress-strain curve is absolutely critical, as it describes the fundamental behavior of a material under a tensile load. On a typical stress-strain diagram, the y-axis represents stress, symbolized by sigma, and the x-axis represents strain, symbolized by epsilon. The first part of the curve for a material like steel is a straight line, known as the linear elastic region. In this zone, stress is directly proportional to strain, a relationship defined by Hooke's law. The slope of this line is the modulus of elasticity, or Young's modulus, denoted by E. You can find the formula, sigma equals E times epsilon, in the Mechanics of Materials section of the NCEES FE Reference Handbook. An exam question might give you stress and strain values from this region and expect you to calculate the modulus of elasticity by simply finding the slope. As the load increases, the curve begins to bend, reaching the yield point, or yield strength. This is the stress at which the material starts to deform plastically, meaning it will no longer return to its original shape if the load is removed. After yielding, the material enters the strain hardening region, where it can withstand additional stress as it deforms. The curve continues to rise until it reaches a peak. This peak represents the ultimate tensile strength, which is the maximum stress the material can endure. A common exam trap is to confuse the yield strength with the ultimate strength. Always remember, the ultimate strength is the highest point on the curve. After this peak, the material begins to neck, where its cross-sectional area decreases rapidly and the engineering stress actually goes down until the material fractures. The exam will also test your ability to distinguish between ductile and brittle materials from their curves. A ductile material, like steel, shows a large amount of plastic deformation and a clear yield plateau before it fractures. A brittle material, such as cast iron or concrete, exhibits very little or no plastic deformation. Its stress-strain curve is often a straight line right up to the fracture point, which occurs suddenly. A classic exam question might show you two curves and ask which material is more ductile. You would choose the one with the largest strain before fracture. To remember the sequence of events on the curve for a ductile material, use this mnemonic. Every young student understands failure. This stands for the elastic region, yield point, strain hardening, ultimate strength, and finally, fracture. Mastering these concepts is key to correctly interpreting these diagrams on exam day. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.